The national park that we'll be focusing on today is Carlsbad Caverns National Park, which is located in New Mexico. The challenge that it's being faced with is potential gas and oil development in and around the park area. This Google Earth image shows above Carlsbad Caverns National Park, and as you can see, the area has a very mountainous and rugged terrain, and below ground is where people actually come to visit the park, which is an underground cave system known as Carlsbad Caverns. And in the upper right corner of the picture, you can see the National Park Visitor Center, where people are taken over 700 feet below ground in order to enter the caverns. This is an official map from the National Park System website that shows Carlsbad Caverns National Park in New Mexico, and you can see the border between New Mexico and Texas, which is shown by the red line in the picture, and the green area shows several different caves and trails that you can see when you're at the park. And in the upper right corner, you'll see the Visitor Center, which is also the cavern entrance. So the challenge that this park is being faced with is potential gas and oil development in and around the area. This has both positive and negative aspects. Positively, it can end up increasing oil, which leads to lower energy costs. This also creates jobs for people, and the U.S. can become more independent where oil is concerned. Landowners can also earn money. On the negative side of things, pollution problems can end up increasing. Oil fracking can go wrong and end up hitting city water supplies. Park and the resources can end up being damaged, and health hazards to the population can end up increasing. The picture on the right shows the entrance to Carlsbad Caverns National Park. On the positive side of things, oil fracking can lead to lower energy costs and the increased creation of jobs. It starts with the discovery of fracking, which is also known as hydraulic fracturing. This leads to the production of oil and gas in the U.S., and in turn leads to lowered energy costs because the U.S. is able to produce oil cheaper in the country. This also leads to more money for Americans, and people will in turn end up spending more because of the money that they've saved. Demand will increase in the economy because people will end up spending more and demanding more products, which increases employment because of the increased demand. Overall, we'll have a more improved economy. Another positive aspect of oil fracking is the increase in U.S. independence and the possibility of money for landowners. An increased amount of oil in the U.S. leads to a decreased dependence on other countries. This is because the U.S. gets to control the price of oil, so if the U.S. is able to produce oil for a cheaper amount of money in the country as opposed to overseas, then the U.S. can end up selling to consumers oil for a cheaper price in the economy, and consumers will end up saving money and in turn spend it in the economy, overall improving it. Landowners will also have to lease their property to oil companies if they wish to do so, and they're actually leasing below ground to the oil companies, not their above ground property. And if the companies end up striking oil, the landowners could receive thousands of dollars in royalties from the companies. This leads to more money in people's pockets and, again, an improved economy. A negative aspect, however, is increased air and water pollution. Power plants in the area, oil and gas wells, as well as refineries within the area will end up increasing, which leads to an increase in truck traffic as well as gas emissions. This can end up creating more pollution in the air and harm both the atmosphere, the ozone, the ecosystem, as well as the population's health. Chemicals used in fracking, and fracking can also disrupt gas and oil deposits. Both of these can end up leaking into the groundwater, and it can end up infecting the drinking water for the Carlsbad city. And on the right side, you'll see a picture of chemicals leaking from a drilling well and seeping into the drinking water aquifer. Another downside to fracking for oil is the possibility of damage to the park and its resources, as well as the health hazards that are posed towards the population. An oil spill would be devastating and would destroy the groundwater and seriously harm the ecosystem. Also, millions of gallons of water are wasted during the fracking process. Over 5 million gallons of water are used daily for fracking. There are also unknown effects to the underground caverns as well as the city, whether that means a possible cave-in or damage to the cave formations such as stalactites or stalagmites. There's also a possible sinkhole in Carlsbad City that everyone is being warned of, and if oil fracking goes wrong, it could possibly trigger the sinkhole and it could collapse. Fracking fluid, as I mentioned earlier, can end up seeping into the groundwater that people drink, and it actually contains toxic chemicals such as benzene, toluene, and formaldehyde, and this can seriously harm people's health. Statistics have also shown that the babies born within 3 kilometers of oil fracking suffer from poorer health, whether from the air or water pollution. Next, we'll focus on the geology of Carlsbad Caverns, which starts with the Permian Age, when a shallow sea containing the Capitan Reef was located where Carlsbad Caverns currently is, and the reef led to the creation of limestone due to the compilation of fossils. This led to the formation of the caverns due to the breakdown of limestone in the area, and ends with speleogenesis, which is the growth of cave formations. The picture on the right side shows the inside of Carlsbad Caverns. Carlsbad Caverns starts way back in the Permian Age. A shallow inland sea during this era contained a reef called Capitan, and Capitan Reef was composed of sponges and algae, which is not like our typical reefs that we see today, which are composed of coral usually. Many of the marine fossils included ammonites, bivalves, brachiopods, crinoids, nautiloids, snails, and as many of you may have heard before, trilobites. A picture of what Capitan Reef supposedly looked like during the Permian Age is shown in the upper right corner. And the coastline led to the creation of limestone that was 1,800 feet deep, 2 to 3 miles wide, and over 400 miles long. This reef ended up being covered in sediment by the end of the Permian Age. However, through faulting, folding, and overall stress to the Earth's crust, it ended up being unearthed later on. Next, Carlsbad Caverns was slowly and painstakingly formed through hydrogen sulfide-rich water traveling underground through the limestone deposits. This hydrogen sulfide ended up combining with the oxygen from rainwater that seeped from above ground, and the combination led to the creation of sulfuric acid, which breaks down limestone. So this sulfuric acid dissolved the limestone along its folds, faults, cracks, and fissures, and this slowly led to the creation and formation of Carlsbad Caverns. Gypsum deposits, clay, and silt were all left behind as evidence as to how Carlsbad Caverns was formed. The picture on the left shows the Chandelier Ballroom in Lechuguilla Cave in Carlsbad Caverns, and the white substance that you see are giant gypsum deposits And these gypsum crystals are supposedly some of the largest formations in the world. The formation of Carlsbad Caverns ends with speleogenesis, which is the creation of all of the cave formations inside. The collapse of the entrance, as well as surface erosion, created the natural entrance that is now the entrance to the system of underground caves. And this collapse in surface erosion led to the opening of the caves so that air could flow through it, and this airflow started the final stage of growth in the cave system. Speleothems are actually cave formations, and these are formed from water from rain and snowmelt soaking through limestone, and this water drips into the caves and evaporates, and minerals carried by this water that soaked through the limestone are left behind when carbon dioxide is released into the air from the evaporation of the water. What usually remains is calcite, and that is why most of the formations in the caves is composed of calcite. Some ceiling formations include curtains, draperies, ribbons, soda straws, and stalactites, and the picture in the upper right corner is called the Doll's Theater, and this shows soda straw stalactites, and they are very fragile. Ground formations include cave pools, flowstone, lily pads, rimstone dams, shelves, stalagmites, and totem poles. These are several formations that are found and widely known in the caves. The first picture, known as the Crystal Spring Dome, is one of the largest active formations and very popular to the public. The middle picture, called the Chinese Theater, shows the formation of columns, which are when stalactites and stalagmites meet together. The last picture shows the formation of a totem pole, and totem poles are created from one single drop of water dripping in the same exact spot for many, many years. So the question is the oil worth damaging this beautiful underground system of caves known as Carlsbad Caverns National Park? And these are the resources that I used to look up information regarding Carlsbad Caverns National Park and the challenge that it's being faced with, which is potential gas and oil development.